So that's when we get with Le Chatelier's principle. So here's the definition. It's a little wordy, but we'll talk about this as we go. What is Le Chatelier's principle? If a change in conditions, which we call a stress, is imposed on a system at equilibrium, the position will shift in the direction that reduces the change. So that's key here. Our goal is to reduce the change, right? So that's what we want to kind of think about as we're going through this topic. So we can kind of put this into like 3 steps to simplify it a little bit. So 1, think about these 3 steps as we're going through Le Chatelier's. Stress is applied. 2, the system responds. How do we respond? That's with our shift. Right? We're going to either speed up one direction of the reaction or the other to try and do what? Reduce the change. So that's the other thing we want to remember here. The goal is to reduce the change. Right? We underline that right here. The goal is to reduce the change. So keep that in mind. So stress is applied, system responds, and then step 3, what are our new concentrations? How have our concentrations changed? Right? So remember, the stress isn't something that we want. It's imposed on the system, and the system is trying to respond in a way that reduces the change. All right, so keep this in mind, these 3 steps, and we'll keep highlighting those as we go through the lesson. All right, so this is Le Chatelier's principle now. So I have this little worksheet here that we'll go through as we're going through this lesson. So if you want to print this out and write this stuff in as we go, or just print the notes out when we're done, whatever you want, or you can download this onto your tablet and write on here with a stylus, whatever you want to do. It's your choice, but I suggest you record these notes in some way or another, rather than just sitting there staring. So now we're going to talk about the factors that affect our equilibrium. So keep in mind Le Chatelier's, right? Stress is applied, system responds. What are your new concentrations? And the goal, reduce the change. Keep thinking about that as we go through this stuff. All right, so let's start off with concentration. First one, so the amount of substances involved. So there's 2 ways I can go here. I can either increase the concentration or decrease the concentration. If I increase the concentration, we're going to shift in the direction that consumes the added substance. We're using up added substance. All right, so because why? Keep thinking. We want to reduce the change. So if I add something, I want to respond in a way that's going to take that away, reduce the change, all right? So we like to say you shift away from what is added, right? Shift away from what is added. So just keep thinking that as we go through this stuff. It'll make things a lot easier. And then if I decrease the concentration, I'm going to shift in the direction that produces the removed substance. We're going to shift in the direction that produces the removed substance. You want to put it back. So you want to shift towards what is taken away. So if you take something away, you want to put it back. If you add something, you want to take it away, because the goal, reduce the change, okay? So you want to shift away from what's added towards what's taken away. So these kind of 2 things are important. It's easy ways to simplify what's going on. It's going to carry over into the next factor as well, right? Away from what's added, towards what's taken away. So I'll show you what I mean by that with an example here. So when I say towards and away, think about you're right here, right? You're standing on the reaction arrow. So that's your reference point. When we talk about shifting right, shifting left, whatever, you're on the reaction arrow. So that's the left, that's the right. So this is the reaction we were talking about before. So what if I change the concentrations of some of these things? So let's say I increase the concentration of carbon. So remember, these brackets mean concentration. So here's carbon. Say, okay, where's your carbon? There it is. So if I increase the concentration of carbon, what does that mean? I want to shift away from what is added. So here's your carbon. So I want to shift away. I want to get away from it. I want to shift away from the concentration. So I'm going to shift to the right. So now what happens when I shift right? So what are my concentrations? So remember, it's a three-step process here. 1, stress is applied. 2, the system responds. And then 3, what are our new concentrations? So those are the 3 steps taking place. So here's my stress. My system responds by shifting right away from what's added. So now if I shift right, if I move right, think about what that means. So imagine you are physically moving away from these guys and towards carbon dioxide. So think about apparent size, right? If you're driving in your car and you're driving towards something, it appears to be getting bigger. And if you're driving away from something, it appears to be getting smaller. So think of that here when we're talking about this. If I'm shifting right, whatever you're going towards gets bigger, and whatever you're going away from gets smaller. So carbon and oxygen are going to decrease, and CO2 is going to increase. Okay? That's it. All right, so whatever you're going towards gets bigger, whatever you're going away from gets smaller. So now let's go the other way. If I decrease oxygen, then what's going to happen? Think about what we said before. Shift away from what's added and towards what's taken away. So if I take oxygen away, I want to put it back, reduce the change. So I'm going to shift to the left, towards what's been taken away. So if I shift left, now I'm moving this way. Let's get rid of this. Now I'm moving this way. So now whatever I go towards gets bigger, and whatever I go away from gets smaller. That's it. All right, so it's not too bad. All right, we just got to work through this and keep thinking about the main things. What's the goal? Reducing the change. Look what I did. The stress was I took away oxygen. So what do? We respond in a way that's going to put it back. Right? Look at the outcome. We increased oxygen. We put it back. Look back up here. If I added carbon, the goal, reduce the change. Look at my final outcome. I'm taking that away. So just keep thinking about that as we're going through this stuff. All right? So remember, these are not infinite amounts of substances that we're dealing with. They're exhaustible. They're consumable. So if you want to make more of one thing, you have to use up the other. So understand why when I shift right, why are these going down when this is going up? Because if I want to make more of this, I got to use up this. So I'm only going to show you one analogy here, because too many analogies take you away from the actual concept and what's actually going on here in these processes. So I don't like to show you too many analogies, but this is one that's a little bit helpful. Let's say I'm making some sandwiches. I'm making bologna sandwiches. So the carbon is my bread, and the oxygen is my bologna. So I need bread and bologna to make a bologna sandwich. All right? So just think about the amount of substances involved here. If I want to make more sandwiches, I'm going to use up bread and bologna to do that. So if I want to make a lot of sandwiches, more sandwiches, that's going to use up bread and bologna to do that. Okay? So that's why these are going down. Think about it, you have a stack of bread and a stack of bologna. The more sandwiches you make, the less bread and bologna you have because you're using it to make sandwiches. Right? So these are not infinite amounts of substances that we're dealing with. They're consumable. So using up one to make the other, or vice versa, is really what's going on here. And that's going to affect your concentrations of your substances. So stress is applied, system responds, what are your new concentrations? And the opposite is true as well, right? I can break things down. If I say I had some people over, I made a bunch of bologna sandwiches because I really want to impress them with my high cuisine, and then the party's over, not a big turnout, only a couple people came, and I made a lot of sandwiches. So I don't want to waste those sandwiches, and I don't really have enough space to store a bunch of sandwiches, so I'm going to break them back down into bread and bologna. So I'm going to take those sandwiches apart, put the bread back in my bread bag, put the bologna back into my bologna bag there, and then I'll put it back in the refrigerator, right? So the more bread and bologna I make, the less sandwiches I have. So this can go in either direction, right? I can use the bread and bologna to make sandwiches, or I can break the sandwiches down to make more individual bread and bologna, right? So that's as far as I'm going with analogies, but maybe that was helpful. Maybe you just fast forwarded to that whole part and moved on. Might have been a good choice. So next factor, temperature. So temperature, we want to think of that as similar to concentration, right? We can add it, we can take it away. So if I increase the temperature, what's that going to do to the system? Remember, we want to reduce the change. So if I increase the temperature, we're going to shift in the direction that absorbs heat. We're going to shift in the direction that absorbs heat. We're going to favor the direction that consumes energy. We want to shift away from the heat. So equilibrium shift in the direction that absorbs heat, the endothermic process. Right? Remember, endo, energy is entering. So think about our towards and away that we talked about before. We want to shift away from the heat. Why? Because we added heat. So think about increasing the temperature as just adding heat. So shift away from what's added, exactly what we spoke about before. Now if I decrease the temperature, then we're going to shift in the direction that produces heat. That's our exothermic process. So what did we say before? We want to shift towards what's taken away. So shift away from heat when it's added, and shift towards the heat when it's taken away. All right, so think about decreasing the temperature as taking away heat, and increasing the temperature is adding heat, and then the same rules apply as before. Shift away from what's added and towards what's taken away. So let's look at an example here. So now you'll see the energy in the reaction here. There's my heat. Sometimes they'll put numbers, kilojoules, or they'll just say heat. But treat heat just like any other substance involved in the reaction, any other reactant or product. So in this case, my heat's on the right-hand side. So just use that to help you answer what's going on here. So remember our steps. Stress is applied, system responds. What are our new concentrations? So if I add heat, I want to shift away from what's added. So where's the heat? It's over here. So I want to get away from the heat. I want to shift left. Right, now remember what that means. Whatever you go towards gets bigger. So my H2 and my I2 are going to go up, and my HI is going to go down. And whatever you shift away from gets small. Right? What you go towards gets bigger. Whatever you go away from gets smaller. So that's a left shift. So now if I decrease the temperature, what do I want to do? I want to shift towards what's taken away. So if I take heat away, I want to go towards it. Shift right. So whatever I go away from goes down, going this way, and whatever I go towards goes up. That's it. All right, so same exact stuff as concentrations before. So temperature and concentration are exactly the same. Just look where the energy is and go in the appropriate direction. All right? So away from what's added towards what's taken away. Keep saying that as we go through this stuff to make your life a little bit easier. And again, think about the why too. Why when I increase the temperature, do I move in the away from the heat? Because remember, think about it as a heat source. If I have a fire, if the fire is too hot, move away from it. It's going to get cooler. And vice versa. If things are too cool, move towards the heat source. It's going to get warmer. Because going towards it, you're favoring the exothermic direction. It's going to get hotter. And going away from it, you're favoring the endothermic direction, and it's going to get colder. So the second to last factor is pressure. Pressure is a little bit tricky. Remember, pressure is all about the force and frequency of collisions, how hard particles are colliding, and how often. We did this back earlier in chemistry. And pressure only affects gases, just like any other time we ever talk about pressure. It only affects gases. So there's two things I can do, increase the pressure or decrease the pressure. So if I increase the pressure, think about the amount of particles involved in the reaction. If I increase the pressure, I'm going to shift to the side with less gas particles. And if I decrease the pressure, I'm going to shift to the side with more gas particles. So why? So think about why here, because this is a little bit tricky. I'm going to shift, if I increase the pressure, I'm going to shift to the side with less gas particles. And if I decrease the pressure, I'm going to shift to the side with more gas particles. Because remember the goal, we want to reduce the change. So if I increase the pressure, now my particles are going to be colliding into each other more often. So I want to bring that pressure back down. How do I do that? Shift to the side of the reaction with less gas particles, because I'm going to get less collisions. Right, less particles, I'm going to get less collisions. And that's going to bring my pressure back down. That's going to reduce the change. And if I decrease the pressure, I want to shift to the side with more gas particles, because I'm going to get more collisions. And that's going to bring my pressure back up. Reduce the change. So let's look at our example here. So this is a little bit trickier than temperature and concentration. So NO2 is producing N2O4, and notice it's reversible. So all we care about are gases. So there's my gases. That's all we care about. And now what can I do? All right, we want to count our gas particles first. So remember, nothing means one. So if I have 2 moles of NO2 and 1 mole of N2O4, so you just got to kind of count them. So count them up. I like to write them right there. Circle it. So there's 2 moles of gas on the left, only 1 mole of gas on the right. So if I increase the pressure, how is the system going to respond to that? So stress is applied, system responds. What are our new concentrations? So think about what's going on here. So the left side, let's draw a picture. We've got this, 2 moles of NO2. So we have twice as many moles of gas on the left as we do on the right. So which way do I want to go? So on the right, I'll say I have 3 particles, whatever, all right? And on the left, twice as many, so I have 6, right? So if I increase the pressure, I want to shift to the side with less gas particles, less collisions. That's going to bring my pressure back down, reduce the change, right? So I want to shift right, which means now once you get the shift, it's easy. Whatever you go towards increases, and whatever you go away from decreases. Same things apply as before, right? Now if I decrease the pressure, then what do I want to do? Now I want to shift to the side with more gas particles, because that's going to bring the pressure back up. We're going to get more collisions, okay? So I want to shift left in this case, which means I'm going to end up with more of this and less of this, okay? That's pressure. It's not too bad, but you got to count the number of gas particles involved and use that to answer the question. So see which side has more and less, and use that to determine which way you think it's going to shift. But the same, once you get the shift, it's easy. Okay? Last one is the catalyst. So remember what a catalyst does. We say the catalyst lowers the hill. Okay? So what does that do? By lowering the hill, that's going to increase the rate of the forward reaction equally. So now your reactions are going to speed up by the same amount in both directions. So it's speeding up this way, and it's speeding up this way. So how does that affect your equilibrium? It doesn't. So you're going to get no change in concentration at equilibrium, but equilibrium is reached more quickly because now it's easier to get up the hill, so it's going to happen faster. That's all. So adding a catalyst doesn't shift the equilibrium. All it does is make it easier for the reaction to occur, but it makes it easier by the same amount in both directions. And remember what we say a catalyst does. We say it lowers the hill, but really what we want to say is it decreases activation energy. All right, that's what the catalyst does. It makes it easier to activate the reaction and get up the hill. All right? So that's our fourth and final factor that affects equilibrium.